Here we look at another example of mathematical induction. We will prove 1 cubed plus 2 cubed plus dot 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 plus n cubed equals n squared plus times n plus 1 squared over 4. So following the steps of mathematical induction, step 1, it's the basis step. We're going to well, here I should add for n greater than or equal to 1. And so basis step will start with the lowest number of n equal to 1. If n equals 1, the left hand side, if you plug 1 into the last formula, you get 1 cubed, which is the same as the first term, which means when n equal to 1, the left hand side is just 1 cubed. Another explanation is the left hand side is, if we use English sentence, what it means is the sum of cubes of 1 to n, from 1 to n. So if n equals 1, it pretty much means the sum of cubes from 1 to 1, because from 1 to 1 it would just be just one number. So that's like the sum of cubes of 1. That's just like the 1 cubed. So left hand side, because we're trying to add the cubes from of 1 to n, which is the cubes of 1. And the right hand side, we plug in, we only need to replace n with 1. So we get 1 squared times 1 plus 1 squared, which is 2 squared over 4. And you can see if we simplify the right hand side, that's 1. Simplify the left hand side, that's also equal to 1. And so we can say 1 equals 1. So the formula holds when n equals 1. Now we're going to look at step 2, the inductive step. In this step, we're going to prove a statement. The statement is, if this formula holds for k, then this formula holds for k plus 1. So first we're going to assume, the hypothesis is that this formula holds for k. So assume the formula holds for n equal to k. So we go back here and replace this n with k. So it's like saying the sum of cubes from 1 to k. So the sum of 1 cubed, 2 cubed, and all the way to k cubed. So pretty much you have to do on the left hand side, you just replace n with k. So you get the sum of all the cubes. One thing we need to remember is the left hand side is a bunch of terms. It's not just n cubed. So sometimes the students will make mistake, they just get k cubed, missed all the previous terms. The left hand side is adding n numbers. Which n numbers? 1 cubed is the first number, 2 cubed is the second number, and so on all the way to n cubed. It's the last number. So here we have k numbers instead of n numbers. And on the right hand side, all we need to do, because we don't have n numbers, we just have one number, one expression. So we replace n with k. So if the formula holds for n equal to k, that means 1 cubed plus cubed plus dot 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 all the way to k cubed equals k squared times k plus 1 squared over 4. But we want to prove this the formula holds for n equal to k plus 1. So first let's write down what the formula is if n equals k plus 1. So if n equals k plus 1, the left hand side will be adding the cubes of 1 and 2 and 3 and 4 all the way to k plus 1. So let's write on the left hand side 1 cubed plus 2 cubed plus 3 cubed all the way to the last one is k plus 1 cubed. in order to compare the left-hand side of this new formula, which we need to prove, and with the formula we already have, I'm going to write down the term right before this one, because we're adding the cubes of all the integers, all the whole numbers. So k plus 1, the integer starting from 1, 2, 3, all the way to k plus 1, and k plus 1, the integer right before k plus 1 will be k. So that's k cubed. So if we compare the left hands, we can see we are only the new formula that went in. This is the formula. So this is the formula, the formula we have. It's for n equal to k. But the formula we need to prove is for n equal to k plus 1. And the right hand side, if we plug in, we will get 4 on the bottom. The top, you're going to replace this m right here with this m with k plus 1, and this m with k plus 1. So we're going to get k plus 1 squared times k. If we replace this m with k plus 1, there's another plus 1, and we will get k plus 2 squared. And this is the formula for n equal to k plus 1, which is what we need to prove. So how do we prove this? We start with what we have, and we compare the left-hand sides. We need an extra term, k plus 1. So we're going to add k plus 1 cubed. I'm sorry, not k plus 1, it's k plus 1 cubed. So let's add k plus 1 cubed to both sides. Then we will get, so let's copy the original left-hand side, 1 plus dot 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 plus k cubed. So that's the original left-hand side. And now I'm going to add one more term to the left-hand side, k plus 1 cubed. Now when we look at the new left-hand side, that's exactly the left-hand side of in the formula for n equal to k plus 1. And the right-hand side, I'm going to copy the original right-hand side, and I'm going to add k plus 1 cubed to the right-hand side. And now if we take a look at the right-hand side, this is what we need. The bottom 4, we already have a 4 there, but the top is different. So as we can see on the right hand side, we only have one fraction, a single bottom. So that tells us we need to combine these two fractions to get one single fraction. So by using algebra, we know that when we add fractions, we need to, we can put the second one as 4 on the bottom, as 1. Put k plus 1 cubed over 1. That's going to make it look like a fraction. And in order to add fractions, we need to equal the denominators. So let's multiply the LCD, least common denominator, 4. And now we can add the numerators. So copy the common denominator 4 and add our numerators. 4 times k plus 1 cubed. And now, without multiplying the top out, we can see there is a greatest common factor, k plus 1 squared, k plus 1 squared. Because we have a cubed, of course, it contains squared. So we're going to factor out k plus 1 squared. And now we're left with the k squared inside. And this k squared is left, since we factor out k plus 1 squared. And in the second term, we're left with the plus 4 times another k plus 1. And if we distribute 4 to k and plus 1, we get a 4k plus 4. And that's exactly the same as k plus 2 squared by using factoring. So we can write down one more step. Equals exactly the bottom 4, the top k plus 1 squared times k plus 2 squared. So that tells us if we just take the left hand side and the last term, and this equals that. It's exactly the formula we need to prove. So this is how we use mathematical induction to prove the sum of first n the sum of the cubes of first n numbers, integers, whole numbers equals this expression.